Good afternoon, everybody. My name is Jerico Moeyersons, and I will present to you the drone innovation research conducted at ID Lab. I can begin, I will first illustrate some previous projects we already completed. And one of the the two main projects are 5Guards and 3D Safeguard VL. The 5Guards project was actually not 100% drone related, but it's very important. Was also a collaboration with CityMatch, who discussed it before me. And there we researched the quality of service at application level in 5G networks. So what was the idea? Okay, when an emergency case is happening, is there a possibility to have a high priority network traffic going from the emergency responders or camera feeds or drones at the emergency site? Can it be prioritized over the other traffic so that everything keeps working smoothly? Video feeds can go to the cloud, to the command centers without any problems. Actually, this was research to avoid the things that happens at Brussels airport during the terrorist attacks, where the whole network was saturated and not one mobile phone was working anymore. So we did this research simulated with software-defined networking, where we then introduced the network slicing concepts, which can be used in the future 5G networks. And then on the other hand, we have 3D Safeguard VL, and that was actually a research project where the idea was, okay, when there is an emergency use case, can a drone fly automatically to the incident area? Can it fly around several times? Can it see, so it can see everything that is happening? It will then do, it will capture the video feed. It will do not decision support, first object detection, and then can do decision support, meaning that, okay, you have object detection on the first hand, so you can see there is a firefighter, there is a gas barrel, there is a fire, there is a victim laying. That's nice to know, but it's also the decision support was the idea of, okay, can we have a context to these images, saying, okay, when there is a barrel, a victim, and a fire close to each other, this would need to trigger an alert to the responder on scene, the commander on scene, so that they can give priority to that case for aiding that person who needed it the most. These were two projects where also I mainly worked on. And over there, I had the idea was from, okay, my promoter came to me and asked to me, okay, Jerico, can you deploy for me a drone application with a thermal camera, and can you also do some roof inspections? So next to my PhD research, sometimes I develop a little bit. And so I started developing the application. I tested everything on my computer. Everything was working very fine. And then after some tips and tricks, I could deploy it on the drone, plugging into my computer, making sure that everything was compatible with the drone, and everything was working fine. So I was happy, and my promoter was happy. And then the promoter came again to me and he said okay, we do the roof inspections. Can we also find missing persons, for example, during a search and rescue? So I said, no problem. I started developing again. I developed it on my computer. It was pretty simple. I have to test to make sure that everything was working on the drone itself, on the drone hardware itself. But then during deployment on the drone, the battery was almost empty, so I had to replace the battery, but we only had one, so I had to wait till the battery was fully charged before I could start deploying again. And then once the battery was charged, once everything was deployed, the law of Murphy came around and the drone crashed completely, so I start all over again. And then to make the whole story complete, we used a thermal camera, but the manufacturer said to us we do not support it anymore. It's completely deprecated. So you have to switch to the newer type of camera. But it's a complete other API, complete other source code. So you actually have to start over all again. So for me, I was going completely nuts. I have to do all the work over and over again. So then the moment we started thinking from, can there not be a better solution for drone development? And because we are also a research team with the cloud, there was the opportunity. So what is actually the problem statement when you develop something for a drone? A developer must take several things into account. First of all, you need to know the hardware type of the drone, which processor, how many RAM is there available, how many force has the processor. Also the power constraints, but of course, the battery is also very important when flying a drone. The load constraints, how heavy can your application be? Also the battery charging during developing could be an issue. So we thought from, okay, can we not bring the cloud technologies to drone development? And that is actually then the idea of our latest research, namely UAVs as a service, containerized drones. And what is the main idea? Well, we used an open source autopilot, the Pixhawk 4 autopilot, which then connects to the rotors, the battery, GPS, and everything other important to the drone. And we connect it to an onboard computer, mostly a Raspberry Pi. So that Raspberry Pi can also then be connected to the cloud. And what is the idea? Okay, we will, on the onboard computer, we will deploy an application called MAF SDK, allowing us to also pilot the drone from an application to, for example, say, lower a little bit of descent or gain altitude a little bit to correct some things. And then we can deploy an application on the drone, on the cloud, but it doesn't matter, depending on what the requirements of the applications are, to deploy it. And to have a bigger overview, so that's actually the same figure, but a little bit more detailed. So if your the Mavlink router is actually a component which is very important, because that allows us to command the drone from any other application on the drone or in the cloud. So what is our most important component? That's the UG1 API. And that's an API which is actually deployed on the onboard computer. And that one will manage the running containers on the drone, and it will communicate with the backend API, a database, a web application, in order to manage everything and manage your whole the drone itself or other drones that are also using this system. And then with an application you deploy, you can choose to communicate with the backend that we provide, or you can choose an all other system where you want to communicate with. That's free of choice. We also then have the Mavlink, who needs to be connected in order to connect to, for example, ground station control applications. And this is a system actually completed. And the moment we want to deploy something, okay, you go to the web application, you select the drone you want to deploy to, you select, okay, I want a container on the drone, so you can deploy it over there. It will happen automatically with the correct specifications. And for example, then you can set, okay, I want to use the camera and the GPS module. It needs to be used by my application. So that's the main idea. And also over there, there can be communication between everything. So what is actually the main idea? As a developer, it will be a little bit more easier to develop and deploy for a drone. You just, as a developer, need to develop a Docker container in taking into account which is the processor type of your drone, but it's a Raspberry Pi, so we can choose ARM processor type. We develop containers, we can put it somewhere on Docker Hub or some private registries. And then the moment somebody wants to use an application, he can just open his computer, go to the web application. He can see, okay, these containers are available on my drone. And he can just click to deploy something on the drone or in the cloud, or let the system decide by itself where it should belong to. And then, so that was the first step. We had one drone, we had a cloud, we did everything with Docker. And then next step was, okay, we can have multiple drones. We can have 3, 4, 5, even more drones. And we have a cloud system which can be getting larger and larger, have more resources. So it needs to be orchestrated better. And then with the idea, we used a lot of Kubernetes, which is a very common cloud container orchestration platform. but it has also some derivatives called, for example, K3S, which will be deployed on the cloud. So it was the whole cloud was managed through Kubernetes, but it's called now K3S, and we could actually add the drones as a worker node on this system without a lot of overhead. There is a tiny little bit of overhead on the drone itself, but it's very, very lightweight, and that makes it able to just deploy applications from the cloud to the drone, or in the cloud itself, and also to manage your drones that are flying, or to have a good overview from this cloud solution. So taking everything I said into account, that's a little bit the summarizing of my PhD research I'm at the moment finalizing. So the main ideas, we have the cloud on the first hand, and we have, for example, 2 drones that are flying around. The first drone is, the drones are connected to the cloud with K3S, as stated before, and they are connected to the network, to the cloud, which is of course necessary, and we suppose it's the 5G networks of the future that they are connected to. And one drone is, for example, taking some nice nature footage, and the other is inspecting some industry sites for a task, for example. So all these video feeds are then processed on the cloud, the GEM tool on the first hand, and also the nature on the second hand. And the whole cloud itself is also monitored very closely to make sure that everything is running smoothly and there are no problems. But then the moment a large fire can occur, so there is one drone on the scene, so he can be used to aid the first incident responders. And the idea is the network traffic that the drone on scene has must be prioritized over the other network traffics for the drone. So the nature imaging is not really important now at that moment. The main idea is, the high priority slicing must go to the drone that is on the emergency use case, and the other drones can use the remaining bandwidth on the network. And also in the cloud, we can then prioritize the containers, making sure that the container who does the processing for the emergency use case have all the resources required, while the other ones have to then divide and conquer with the remaining available resources. So what are other drone projects we are now currently looking into? Construction site inspections is something of main interest, and also machine learning at edge, because now we have our drones as an edge device connected to the cloud. So can we also apply the machine learning on the drone itself, taking into account also the load constraints, the power constraints, and the limited resources available? So that are projects we are currently looking into to eventually start. Some publications you can read if you're interested in about everything what I said today over here. So it's a compilation of everything that is related to the research conducted. And then to finalize, I would just add a call that we are always open at ID Lab, University of Ghent, IMEC, to brainstorm or to discuss potential avenues for collaborative research in both national and international research projects. So as Elwin stated before, feel free to contact them or us in case of questions, and we are happy to help. Thank you for your attention.